My name's Beth Ann Bell, and I work on the early Earth. We have a rock record on the Earth that stretches back to about 4 billion years, and a mineral record that stretches back to about 4.3. So I'm taking what we know from the pre-rock record era and trying to figure out what transitions there might have been between that era and the time period in which we have a more complete rock record. Most of my work, my analytical work that I do, is on the ion probe. So a lot of the times I'll be prepping samples for that, and I've got an example here. This is an epoxy mount with about 400 pieces of the mineral zircon in it. These are probably hard to see. I think they're only 100 or 200 microns or so across. But basically, this mount we coat in gold and put into the ion probe, and then we can analyze various aspects of the geochemistry. We can look at the uranium and lead to get an age date for it. We can look at oxygen isotopes to get an idea of characterizing the rock that it came out of. One reason that I'm looking at zircon is because there is a locality in Western Australia where we can find zircons that get back to 4.3 billion years old, which is very soon after the formation of the planet at about 4.5, 4.6 billion years old. Looking at the early Earth is sort of a planetary comparison for some of our other planets in the solar system, and how did Earth become the way it is today, and I guess maybe looking in the future at exoplanets, what sorts of predictions can we make for the kinds of planets that would become Earth-like, I suppose. Could also be an application. And also just if we can figure out when and how plate tectonics and other various geologic processes on the Earth today began, maybe we have a better understanding of just sort of the fundamental forces behind them.